All right, let's go through and look at radical equations for a second, because they have a special type of solution that I want to make sure that you understand. So, radical equations are equations that have radicals in them. So a radical can be a square root or a cubed root or fourth root, whatever root, but it's that symbol right there. Okay, so this has a radical in it. It happens to be a square root, so this is a radical equation. So how do I get rid of that square root? Well, the opposite of square rooting something is squaring. So if I can get this thing by itself on one side of the equation, then I can kill it by squaring it. So I'm going to get rid of this 11 because he's in my way. And that's going to leave me with the square root of 3x equals x, and then 5 minus 11 is negative 6. Okay, so that's what I have so far. So I've done what my first step is to do, which is to get that radical by himself. And now I can get rid of it, because remember, I can do anything I want to as long as I do it to both sides of the equation. So on the left, when I square it, it's going to reduce out with that radical. And so all that's going to happen on the left is that 3x is going to pop out. Okay, it's kind of like saying this, so I'm going to make something up for you. If I ask you what the square root of 49 is squared, okay, well, I know what the square root of 49 is. It's 7. And now I have to square it, so I get a 49. So if I square something with a square root, the argument just pops out. Okay, the argument just pops out. So that's why that 3x is popping out. And now I'm going to go ahead and expand this. I'm going to remember that this is x minus 6 times x minus 6. So I am not just going to say x squared plus 36. So when I FOIL that out, I get an x squared minus a 12x, because I get negative 6x and negative 6x. And then negative 6 times negative 6 is positive 36. Okay, so now I'm back in quadratic land, which is where you've been this week. And so I can factor this thing down once it's set equal to 0. So I'm going to get rid of this 3x. So you go away. So now what I have is 0 equals x squared minus 15x plus 36. And I can go ahead, we've brainwashed you into all of your variables being on the left. So let's go ahead and push everything to the left. So I just flip-flopped everything. That was really fast. I flip-flopped everything. Okay, so this is quadratic. This is factorable. I need two numbers that multiply to 36. Your signs are the same, that add up to negative 15. And I factored it wrong, which is why I'm interrupting the video. So what do I get is two numbers that multiply to 36 that add up to a negative 15 are a negative 12 and a negative 3. I was not paying attention and I almost led you astray. All right, so now I got two factors. When I multiply, my answer is 0, so one of those two factors must be 0. So I'm going to add 12. So on this factor, if x is positive 12, then 12 minus 12 is 0, and 0 times all that stuff is 0. Okay, grab your x minus 3 and add 3 to both sides. So I get x equals 3. So if I put a 3 in here, 3 minus 12 is negative 9, 3 minus 3 is 0, negative 9 times 0 is 0. So what I want to do now is check my answers. I need to check my answers. So I'm going to go back up to the original problem, which was the square root of 3x plus 11 needs to equal x plus 5. And I'm going to check these things. So there's a danger when we're dealing with radical equations that we might do everything right, but something blows up in the end. So I'm going to try 12 first. So that gives me the square root of 3 times 12 plus 11 is 12 plus 5. So this is the square root of 36, which is 6, plus 11 is 17, and 12 plus 5 is 17. So I like 12. 12 worked. So 12 is one of my answers. Now let's check 3. So when I check 3, the square root of 3x plus 11 equals x plus 5. I'm going to get the square root of 3 times 3 plus 11 is 3 plus 5. So this is the square root of 9. Square root of 9 is 3. So 3 plus 11 is 8. Well, 14 does not equal 8, which means 3 led me down a path that I don't want to go to. So there's a way that we phrase this. I have a single solution, and that single solution is 12. I have an extraneous solution of 3, but I'm not going to list it. So extraneous means I did all my math right, but when I checked my answer, something went wrong. I did all my math right, but when I checked my answer, I went wrong somewhere. So 12 is your only answer. You cannot use both. Okay, so that is the problem of the week.